Okay, this is lesson 7.2. We're still doing inequalities. In this lesson, we're going to write two-step inequalities. So that basically means we're going to write an inequality from a situation or from a word problem. We're not going to solve the inequality yet. We're going to do that in 7.3. We're just going to be writing the inequality, okay? So step number one, you want to ask, what are you trying to find in the problem? Whatever you're trying to find in the problem, this is your variable. Okay, what the number or value that you're looking for at the end of the problem, that is your variable. Once you figure out what your variable, you find the important information from the situation and find words that can help you figure out operations, which means adding, subtracting, multiplying, and dividing, okay? And then you write your inequality. So let's try to do this, okay? Doing this, writing an inequality or writing an equation from words or from a situation, you really have to pay attention to the words, okay? So let's read this. A mountain climbing team is camped at an altitude of 18,460 feet on Mount Everest. The team wants to reach the 29,029 feet summit within 6 days. Write an inequality to find the average number of feet per day the team must climb to accomplish their goal. Now, this sounds pretty complicated, doesn't it? We're just going to take it one piece at a time, okay? Step number one, what are you trying to find? So let's figure that out. It says, find the average number of feet per day the team must climb. So we're looking for feet per day right there. The team must climb to accomplish their goal. So we also know, though, that they want to finish within 6 days. So we're going to make a number of feet, okay? Number of feet gained per day. That's going to be our variable, okay? So let's make our variable F, let's say, feet to stand for feet. F stands for feet gained each day, okay? Number of feet, find the average number of feet per day the team must climb to accomplish their goal. So this is the number of feet that they're going to climb each day, okay? That's our variable. Well, we also know that they want to finish this in 6 days or within 6 days. So 5 days is fine, 4 days is fine, right? So if they want to finish within 6 days, what is the number of feet they have to travel? Okay, so this is feet per day. So anytime you see feet per day and you do 6 days, you're going to multiply. This is the feet for 1 day, and then they want to go 6 days. That's, you know, the same number of feet per day is multiplying. So you basically, that we know that is 6F, okay? That's how much they're going to gain each day. Well, the important information, so we skipped things because I found words to help me with operations. Per day, I know that's either multiplying or dividing, but I also know it's 6 days. So I'm going to multiply the 6 times the feet, okay? That's a word that helps you with operations. Now, it also says that they are already at 18,640 feet. So that tells me if I take where they are now and add it to the number of feet that they're going to climb each day, then I want them to reach the summit, 29,029 feet. This is the top. This is where they're trying to get, okay? So if I take where they are now, okay, plus the number of feet that they're going to travel each day, multiplied times 6 days, I want all of that, okay, to be greater than or equal to the 29,029 feet that they want to reach by the end of it. The reason this is greater than or equal to, because this number of feet, if it's greater, then they'll reach the top in less than 6 days. Okay, if this number over here is greater than 29,029 feet, then they will reach the top in less than 6 days. If this number over here is equal to 29,029 feet, then they will reach the summit exactly on 6 days. Okay, so it's okay if they reach it early. They just can't reach it late. They can't take more than 6 days. They can take 6 days or less. So the number of feet that they have to travel each day has to be a number that will either put them over the summit or at the summit in 6 days. Okay, so we're looking for a number of feet for each day that they travel. Okay, so let's, that is how you write that inequality. Okay, let's try another one. Now, these are not easy. So if this is sounding confusing to you, that's, you know, that makes sense that it would sound confusing, because anytime you're trying to take the words and turn them into an equation or an inequality, it can be difficult. You have to really understand what the problem is saying, okay? This says Manny buys 2 work shirts that are each the same price. After using the $20 gift card, he can spend no more than $50. What is the maximum amount he can spend on each shirt? Maximum amount tells me that is the most he can spend. He can't spend any more. He can spend less, that's fine, but he can't spend more, okay? So he buys 2 work shirts, and I'm looking for a price for 1 shirt or each shirt. So I'm going to make the P be the price for 1 shirt. Okay, but I know he's buying 2 shirts. So that's 2P, okay? And then it says after using the $20 gift card. So I'm going to take the 2P and I'm going to take away the $20 gift card. So this is the price of the 2 shirts. This is the price of 1 shirt, but I multiply it times 2. That's the price of 2 shirts. I'm going to take away the $20 gift card. All of that is basically going to be greater than or equal to 50, right? So the reason that, actually not greater than, all of it's going to be less than or equal to 50. Here's why. 50 is the maximum amount he can spend, okay? So this has to be less than 50. This total amount has to be less than 50, all right? So that is the equation, because he can spend 50 exactly, which is why the equal sign is there, but he can't spend more than 50. He can spend less, but he can't spend more. So all of this has to be less than or equal to 50. And that is basically 2 examples of inequalities written from the words, okay, which is all you're doing in this lesson, is writing the inequality.